Hello, my dear friends. I'm Shubham from LearnoHub, the free learning platform where you can study physics, chemistry, maths, biology absolutely for free at learnohub.com. So then, let's start. So friends, as you all know, we are studying your ICSE chemistry class 10th, right? Chapter number 7. And in this video, we are going to cover all the concepts of this chapter, metallurgy. Also, along with it, after a particular topic, we are also going to solve some questions which have been asked in your previous year exams, so that you would get a fair idea that how questions are being asked from this chapter. Okay, so without wasting much time, let's start and let's rock. So before starting to study this chapter, metallurgy, first let's try to understand why we should study metallurgy. Okay, but before that, let's first understand what is actually metallurgy, right? It may be a new word for you. So metallurgy is a very simple process of extraction of metals, okay, in its pure form. So we are extracting the metal in its pure form from its ore. Okay, now don't go into details right now about the ores, because we are going to study about ores and minerals and all those things in very detail. Just simply understand that we are extracting metal in its pure form from its naturally occurring compound. Okay, this is called metallurgy. Very simple. Okay, but now why we should study this process of extraction of metal in its pure form from its naturally occurring compound then? Right? What is the need? Because if you don't study this process, how you would get the metal in its pure form? And if you don't get the metal in its pure form, how you can use the metals, right? You can see around you, there are thousands and thousands of applications of metals you use every day in your life, right? So if you don't study this process, okay, you won't be able to get the metal in its pure form. And if you don't get the metal in its pure form, you won't be able to use it, right? So for that purpose, yes, we need to study metallurgy. And now in this chapter, which metals extraction in its pure form we are going to study? We are going to study aluminium's extraction. Okay, so I hope you are now convinced for learning this chapter and you are interested as well. So then let's start. So first, let me tell you the division which I have made for this chapter. Okay, I have divided the chapter into 3 parts, and the first part is the basics which we need to study in order to understand the next part, the extraction of aluminium part. Okay, now in this basics we are going to see occurrence of metals, minerals and ore, what are minerals, what are ores, and some common ores of aluminium, zinc and iron. Okay, after that we are going to quickly jump on this topic, extraction of aluminium. But before that, let me tell you, very few number of questions are being asked from this basics. Okay, but yes, questions are being asked, right? So we cannot skip this part at all. Okay, the next part, extraction of aluminium, Bayer's process and Hollerald's process, we are going to see it in very much detail. And yes, you have to pay much attention to this, because so many questions are being asked in your previous year exams from these 2 topics. Okay, and the last one is alloy. Okay, we are going to study what is alloy and the composition and uses of some alloys. Okay, there are some alloys which we have to study in our syllabus. So regarding only that alloys, we are going to study their composition as well as their uses. And yes, this part, though it is small, but yes, so many questions are also being asked from this part. Okay, so I hope I have given you a basic idea about how questions are being asked from which topics, means questions are being asked from which topics. Okay, first of all, so you would get a fair idea that which part is important in the topic and which part is slight important. Okay, but we are going to study all the things, right? Fine, so let's start from the basics. So first, let's see how metals occur in the nature. Okay, but before that, you should know a very interesting thing, that our Earth's crust, now all of you may be knowing what is Earth's crust, the Earth's uppermost layer, right? This Earth's crust, our Earth's crust, is the biggest source of metals. Okay, so you would find most of the metals in the Earth's crust. So very easy job, right? Now what we need to do is we need to just dug the Earth's crust and take out the metals, but it's not that easy. Okay, why? Because metals are not like that much, they are not making the process that much easy and comfortable, because they are existing in 2 different types. Okay, either they are existing in the free state, or we can say that free state as a native state, it's another name, or the metals exists as combined state, in combined state. Okay, now what is this free state? So you would find the metal, okay, which in this type of state you would find metal which is not associated with any other element. Okay, it is simply that particular metal's rock or particular metal's cube you would find from the Earth's crust. Okay, for example, gold, platinum, these two metals, okay, they are not associated with any other element. Okay, you would just find them as it is. Okay, the gold block or gold rock in this way. Okay, now what is combined state of the metal? Now some metals do not exist alone. Okay, do not exist freely as if like gold and platinum. They exist in a combined state, which means that those metals combine with some another element, okay, and they form a compound. So this is called as a combined state of metals. Now which elements are present in this combined state, or we can find which elements in this combined state? This, see the examples: potassium, sodium, calcium, magnesium, aluminium, zinc, lead, copper, mercury, silver. These are some examples I have picked out. Okay, now let me tell you how they exist. Okay, I have told you they exist in the form of compound and that compound is made of that particular metal with some another element. Okay, so see, potassium and sodium are existing as their chlorides, which means KCl and NaCl. Okay, they are the chlorides of potassium and sodium. Similarly, calcium and magnesium are existing as carbonates, which means they are found as calcium carbonates, magnesium carbonates. Okay, in this way. So calcium and magnesium are associating with carbon and oxygen. Okay, and they are forming carbonates. Okay, and in this type of compound they are existing. Okay, you cannot find calcium and magnesium free in the nature, just like gold and platinum. In this way, aluminium in its oxide, like this Al2O3. Okay, this is called as alumina. Very important. We are going to study in much more detail about this or regarding about this. Okay, and then zinc, lead, copper, mercury, silver. Okay, these metals are existing as their sulfides, which means these metals are combined or they are associated with sulfur. Okay, so for example, I would show you zinc sulfide. Okay, ZnS. Okay, so in this way they exist: lead sulfide, copper sulfide, silver sulfide, mercury sulfide, in this way. So these metals, now the question should be arising in your mind, sir, why is this happening? Some metals are existing in free state in the nature, right? Just simply gold as gold, platinum as platinum, while some are existing in combined state. Okay, this is because, see, we know that these metals are existing as in the free state because they are having very less tendency to react. Okay, they are very least reactive metals. Okay, so if they have very less notion of reacting with some another element, okay, they would be reluctant to react with some another element. So if they are reluctant to react with some other element, they would prefer to leave alone, stay alone, just like there are some friends in your class, okay, but some of them may be some like introvert type. They won't like to mingle with some another students. So you can just compare them with the free state of the metals. Okay, while some other students, you may feel that they are like so much extrovert. They are like talking with anyone they find. They laugh and they jump and they dance with anyone. Okay, so those are like the combined state of metals. Okay, they are like free to mingle. The metals are like free to react, free to combine with another elements. So such metals, okay, which are found in the combined state, this means that they are very much eager to react with other elements, okay, and combine, okay, to form a compound. So which metals are very much eager to react? Which metals have very much high tendency to react? We can say that those metals are reactive metals, right? So since they are reactive metals, they exist in their combined state. Okay, and most of the metals, okay, exist in the combined state because most of the metals are reactive, right? Very less metals are least reactive. That's why most of the metals exist in the combined state. Okay, clear with this part? Okay, now moving ahead to what are actually minerals and what are actually ores. Okay, so first let's start understanding what is a mineral. Very simple. Mineral is simply a naturally occurring compound of metal. Okay, so any compound of metal which is occurring in nature, that is mineral. Okay, now for example, see this Fe2O3, ferric oxide, you may be knowing its chemical name. Okay, so it is called as hematite. Okay, this is a mineral. See, it is a naturally occurring compound of iron. That's why it's a mineral. Same way, bauxite, Al2O3.2H2O, it is having that water of crystallization with it. Okay, two water of crystallizations. So Al2O3.2H2O, this is the compound of aluminium, and since it is occurring in nature, we call it also as mineral. Okay, it is called as bauxite. Okay, so please do remember here, or else we are also going to study it study about the bauxite, okay, use the bauxite very much extensively, okay, when we are doing the extraction of aluminium, okay. But for now, these are the examples of minerals. And what are minerals? Simply the naturally occurring compounds of metals, okay. Now, what is gang or matrix then? Okay, this is a very simple question which is being which they may ask in your exams. Okay, what is gang or what is matrix? Because it is associated with minerals. See, there may be some earthly impurities like sand, soil, okay, mud or silica, okay. So these earthly impurities may be mixed with minerals, okay. And these earthly impurities like sand, soil, silica, mud, which are mixed with minerals, are called as gang or matrix, okay. So first, what we do is we just take out from the earth's crust the naturally occurring compounds of metals, okay. This is our first job, and which we call as minerals. Now let's see what are ores, okay, and how they are different from the minerals. Now, ores are also the minerals, but ores are those minerals, okay, from which we extract the metal on a commercial scale, okay, from which the metal is extracted commercially, okay. And also not only just we are extracting the metals on large scale, commercially means large scale, but also those minerals from which we can extract the metal commercially at comparatively lower cost, okay, and with minimum effort, okay. So if I want to extract iron, okay, now suppose I am having so many minerals with me. This entire square box is full of minerals of iron. But which minerals I would call them as ores? Only some of these minerals, out of this so many minerals, only some of these minerals, okay, I would just analyze, and then I would get to know that only some of these minerals are such that from which I can extract the iron, okay, in pure state, and also at a comparatively lower cost than the other minerals, okay, plus with minimum effort. Now see, we are humans, we always think about the hole in our pocket, right? So this time also we definitely think about the money factor, okay. We tend to spend the money, okay. Like suppose if you know that a certain work can be done in 200 rupees, so if a person would be a fool if that person does the same thing in 2000 rupees, right? So in the same way, we are applying the logic. We are thinking about the pocket in our hole. That's why we are choosing out of these minerals, those minerals from which we can extract our metal in the pure form, okay, at a comparatively lower cost. And also, always we humans always tend to find some easy way, right? So that's why also with minimum effort, okay. So those minerals are called as ores. So out of these minerals, these minerals I found that I can extract the iron in its pure form, okay, at a comparatively lower cost than the other minerals, as well as with minimum effort. So I would call these minerals as ores, okay, out of this all minerals. Now the same simple logic is, see, all the minerals, okay, all the minerals are not ores, right? Some minerals are not ores, we can see here, but all ores, yes, all ores, they are minerals. Clear? So that's it, simply, okay. So once you understand this thing, it's very simple to understand this term, okay, this statement. Now let's see the examples of ores, okay. Now we have seen examples of minerals as well. Now let's see examples of ores, and we have to study the examples of some common ores of zinc, aluminium and iron, okay. So let's see one by one the common ores of zinc, aluminium and iron, okay. Okay, so let's start first with the common ores of aluminium. So these are the common ores: bauxite, corundum, cryolite, okay. So I will tell you also how to remember their chemical formulas as well, okay. So bauxite, I have already told you the example in the mineral itself, and yes, it's very important, you have to learn it, remember it. In fact, you have to learn and remember all the ores which you are seeing on the screen, okay, because they are asked in your exams, okay. They may be asked in your exams, it's very important. So starting from the common ores of aluminium, first is bauxite. Bauxite's chemical formula, very important, very much important, Al2O3.2H2O. Okay, there are two water of crystallization associated with this aluminium oxide. And now its chemical name. Chemical name is very simple. Once you know the formula, you can just try to remember the chemical name, and you just easily figure out from the name itself. See, hydrated, because there is water. So see, hydrated, and then aluminium oxide. aluminium oxide, right? Very simple. Now why I have made it red is because mostly, okay, the main ore out of these 3 common ores of aluminium, the main ore from which we extract aluminium in its pure form is this bauxite. Okay, that's why you need to remember this also. Next is corundum. Okay, very simple. Why I have written it below bauxite? Because its chemical formula is also similar to that of the bauxite. See, Al2O3.2H2O is bauxite's chemical formula. You just remove this water of crystallization, you would simply find the corundum's chemical formula. Okay, Al2O3. Very simple, aluminium oxide. So here, since water is absent, so what we can call it as anhydrous, right? When we remove the water, that compound becomes anhydrous. Okay, anhydrous means water is removed. Okay, so anhydrous aluminium oxide. See, anhydrous aluminium oxide. Very simple. And then last one is cryolite. We are also going to use this later on while extracting aluminium. It's very important. Okay, so cryolite is simply Na3Al(F6). Okay, now its name is also very simple. See, sodium aluminium fluoride. Okay, just the names of the element you have to remember. Sodium aluminium fluoride. This is the name. Simply you can just make it out from the chemical formula. Moving ahead to the common ores of iron now. So these are 4 common ores of iron: hematite, magnetite, iron pyrite and siderite. So I have marked it with red. Now you would have guessed it. This is the main ore from which we extract iron in its pure form. Okay, hematite. Its chemical formula is Fe2O3, ferric oxide. Okay, simply the chemical name also you know. This compound we know it very well. Fe2O3, ferric oxide. Okay. Now next is magnetite. Magnetite is Fe3O4. Okay, so its name is triferric tetroxide. Okay, 3 iron, 4 oxygen, triferric tetroxide. Very simple. Next is iron pyrite. So its chemical formula is FeS2. Okay, FeS2. So iron disulfide. See, iron disulfide. Since its oxidation state is 2 here, so that's why in its name also it's 2. But if you want, you can write the 2 in the name, or else you can also just skip this 2. You can just simply write iron disulfide as well. Okay, and then siderite. Okay, this is iron carbonate, means iron and carbonate is there in this compound. So see, FeCO3. Okay, and now see here the name would be Fe is in its +2 state, right? +2 charge it is having, and carbonate is having 2- charge here. So we know that Fe in 2+ charge, we call it as ferrous, right? Here it is in 3+. Okay, Fe3+. In Fe2O3, you can just calculate the charge. We all know how to now pick out the charge from this. Okay, oxygen's charge is -2 here. Okay, so obviously the iron's charge would be 3+, because they need to balance it, right? So that's why iron's charge would be 3+. That's why it is ferric. See, ferric oxide. Okay, now see here, ferrous carbonate. So these are very basic things you have learned already in your 9th grade, right? Now let's move ahead to see the common ores of zinc. Okay, so there are 3 common ores of zinc, simply zinc blende, zincite and calamine. Okay, zinc blende's chemical formula is zinc sulfide. Okay, ZnS. Name is simply zinc sulfide, ZnS. Okay, zinc sulfide. Okay, very simple name. Zincite is zinc oxide, and the chemical name is zinc oxide simply. And calamine is zinc carbonate. Okay, and name is simply zinc carbonate. Okay, so with this all the knowledge of common ores, what are minerals, what are ores, occurrence of metals, let's see quickly some questions which have been asked from this part in your exams. Okay, so the year in which the question is asked, I have just written it here. Okay, you can refer. The most common ore of iron. Okay, now we have just now seen the common ores of iron. Now they are asking the most common ore of iron is dash. Okay, either it is calamine or hematite. Now we know calamine is zinc carbonate, just now, the last ore which we saw, right? And hematite is Fe2O3, right? The first ore of iron which we saw, and it's the main ore, chief ore, right? From which iron is extracted, right? So yes, our answer would be hematite. Okay, moving ahead. An ore of zinc containing its sulfide. Okay, so sulfide means, now here sulfur is there, very clear, or we can say sulfide means this S2- ion is there. Okay, Now ore of zinc containing its sulfide means zinc is also there. So zinc is also in the 2 plus state, 2 plus charge, sulfide 2 minus charge. So what it would form? Zinc sulfide, right? And yes, we know zinc sulfide is what is the name of the ore? Okay, we need to remember the name of the ores as well. Okay, just remembering the chemical name is not enough. It is zinc sulfide, we know, but the name of this ore is zinc blende. Okay, just now we have seen. So you can go back in the video and you can just refer. Okay. Okay, so far we have covered the basics, okay, which are required to understand the next part, that is the extraction of aluminium. Okay, now we are going to actually extract aluminium in its pure form from its ore. Okay, and now let me tell you one more interesting thing before starting to study the extraction of aluminium, that aluminium, okay, this metal is the most abundant metal in the earth's crust. Okay, the most abundant one. Now just now we have seen the earth's crust is the biggest source of metals, and yes, aluminium is the most abundant metal in the earth's crust. So if you would imagine a choco chip, okay, so most of the choco chips would be of aluminium, right? Now we are going to extract aluminium in its pure form from its ore. But now which ore? I have told you already. We are just going to use bauxite, right? It's the main ore from which we extract aluminium in its pure form. Now bauxite's formula, we know Al2O3.2H2O, but there is some problem with this bauxite. Okay, this bauxite does not, it has some impurities with it. Okay, just like the earthly impurities we have seen, gangue and matrix. Okay, it also has the earthly impurities like sand and all those things. And also apart from that, it also has some impurities like ferric oxide, titanium oxide. Now we don't need these oxides. Okay, neither we need the sand and the earthly impurities. We just want aluminium, right? Pure aluminium. But now since it is having impurities, now we need to purify our bauxite, right? But for purifying the bauxite, now which method we are going to study, and which method we are going to study? It is the chemical method. Okay, we are going to use some chemical in it. Fine. And now in this chemical method, we are going to use an alkali, NaOH. Okay, and what we are going to do is, for purifying the bauxite, okay, in this method, we are going to convert bauxite into alumina. Okay, now we know the formula of bauxite, Al2O3.2H2O. Okay, now alumina is Al2O3, right? This is alumina, aluminium oxide, simply. Now, this process, okay, the chemical method in which we are using this NaOH, okay, to convert bauxite to alumina is given a special name, and it is called as Bayer's process. Okay, clear? So we are going to start studying what actually is Bayer's process, how we are going to purify bauxite and convert it into alumina. Clear? So I have divided this process in 4 simple steps so that you could understand it very much easily. Okay, that's then the job is done. Clear? Okay, now in step 1, what we are going to do is, we are going to take the bauxite and we are going to crush it, we are going to grind it, we are going to make it in fine powder. Okay, and then this finely grinded bauxite we are going to heat. Okay, like this finely grinded bauxite. Now what would happen? After heating, okay, whichever impurities in this bauxite which are volatile, okay, now volatile means, we have already studied this. Okay, volatile means simply those substances which if we are giving them some heat, okay, around 100 degrees Celsius or like that, okay, or even at room temperature also, okay, those substances may get converted into its vapor state. Okay, some of them may get converted into its vapor state at room temperature as well, or some of them may be given, may require some heating around 100 degrees Celsius. Okay, but then they would get converted into the vapor state. So such substances are called as volatile substances. Simply means those substances which can easily get converted into its vapor state. Okay, so such impurities, if which are present in our bauxite, how we are removing it? We are simply heating the bauxite. Okay, by heating, what would happen? Those impurities which can easily get converted into its vapor state, okay, by some heating, they would easily get simply converted into its vapor state. So they would leave our bauxite. Okay, now our bauxite would be free from this volatile impurities, right? In the step 1. Second step, now this is the actual step which we are going to, when we are going to actually start the purification of bauxite. Okay, this was a simple step. Volatile impurities, we have just made them go away. Now comes the removal of insoluble impurities. Now let's understand this, how we are going to remove this insoluble impurities. But what we are actually going to do is, here we are going to take our bauxite, which is finely grinded, fine, and now we are going to take this bauxite along with concentrated NaOH solution. Okay, this. Now this NaOH, okay, it is called as NaOH, we all know it is called as caustic soda. Okay, so you can also say we are taking concentrated caustic soda solution. What we are going to do is we are going to heat it. Okay, let's bring the burner. We are going to heat it around 140 to 150 degrees Celsius. Okay, and also along with heating, we are also going to apply some pressure. Okay, so here we are applying the pressure, we are heating it, and this process we are continuing, okay, for 2 to 8 hours. Okay, so now let's chill out, sit for 2 to 8 hours, let this continue. But now after 2 to 8 hours, suppose now we have chilled out, now after 2 to 8 hours, what has happened? Okay, let's try to understand with the help of reaction. Okay, what would happen? What would happen when the bauxite is reacting with our NaOH? Okay, so I would take my bauxite, okay, Al2O3.2H2O. Yes, we are making it react with the concentrated NaOH solution, right? So this is concentrated NaOH solution. What would happen? See, we have already studied this thing, the concept behind this thing. See, in analytical chemistry, we have studied about amphoteric oxides, those oxides which can react with both acids as well as alkalis, and they would produce salt and water, which means those oxides which simply can behave like both acids as well as bases. Okay, they have both acidic as well as basic nature. Okay, and there we have studied the example of such oxides, of such amphoteric oxides as aluminium oxide. So in the bauxite, what you can see here, see, this is aluminium oxide. So that's why it would react with NaOH. Okay, it is a metal oxide, and metal oxides are basic in nature. Okay, so its tendency would be to react with acids. But since it is amphoteric, it would also react with bases or alkalis. And here it is doing the same thing. See, it is reacting with the alkali, and what it would form? It would simply form salt and water. We have already studied. Just like bases react with acid and form salt and water, this basic oxide would react with an alkali and would form salt and water. Just same as the way like this basic oxide would react with acid and form salt and water. Okay, so our alumina reacts with NaOH. Simply you can just understand here the simple thing. Our alumina reacts with NaOH and it forms salt and water. Now which salt it forms? This is the salt. Okay, this also we have already studied. Sodium metaaluminate. Okay, its name is sodium metaaluminate, and water is formed. Okay, now the reaction conditions, they ask in your exam, see this reaction. Okay, so you need to remember the reaction, and yes, they don't just ask the reaction, they just ask a balanced reaction, okay, along with the conditions. So you can write here the condition 140 to 150 degrees Celsius here. Okay, you can also write the pressure as well. Okay, that's it in the reaction. No need to write the time. Clear? These two things you have to mention in the reaction always whenever we are writing a reaction, and if it is having some temperature conditions, some pressure conditions, you have to mention it. Okay, after that you just simply balance the reaction. Okay, now balancing part won't take much time. See, 2 aluminium, so here you would just make 2 aluminium for balancing it. Then what happened? 2 sodium, so I just made here 2 sodium. Okay, then now after balancing sodium and aluminium, 2 sodium, 2 aluminium, 2 sodium, 2 aluminium, then we would move on to hydrogens. Okay, so here how many hydrogens? 4 hydrogens, and then 2 hydrogens, which means 6 hydrogens. Okay, here there are 2 hydrogens only, so let me make them 6. Okay, after that let's finally check the number of oxygens. So the step I follow here is, see, the other elements first. Okay, other than oxygen and hydrogen, I just first balanced it, then I balanced hydrogen, and then lastly I would check after balancing hydrogen whether the oxygen is balanced or not. Okay, if it is balanced, well and good. If it is not balanced, then I would try to balance it. So see, oxygen, 3 oxygen here, and then 2 oxygen, 4 oxygen. So 4 oxygen plus 3 oxygen, 7 oxygens. So here 2 oxygen, and then 2 oxygen, 4 oxygen, and then 3 oxygen, 7 oxygen. So it's balanced. After that, we have to just go through that After balancing hydrogen and oxygen, the main elements, the starting elements other than hydrogen and oxygen are balanced or not. So sodium and aluminium, so they are balanced, 2 sodium, 2 aluminium. Okay, 2 sodium, 2 aluminium in the same way. Clear? So this is the way you have to balance. I know you know how to balance the reaction, but I'm showing this because next reactions I won't balance. You need to balance it on your own, and they are very simple ones. Okay, now moving ahead, why we studied this reaction? In order to understand what is actually going to happen. Okay, after adding concentrated NaOH solution in bauxite, okay, what would happen is this sodium aluminate would be forming, and this sodium aluminate is a soluble salt. Okay, so it would get solubilized in this water. Okay, so what we would get is this sodium aluminate solution we would get. Okay, NaAlO2 solution. But okay, our alumina is reacting with NaOH, and it is forming a soluble salt and water. Okay, but there may be some components or some compounds which may not react with NaOH. Okay, they would simply remain as it is, and if they would simply remain as it is, okay, after this process, along with this NaAlO2 solution, we would also find some impurities which are insoluble, right? Now we know that we are concerned with aluminium, and in this reaction our aluminium is here in this sodium aluminate. Okay, and we know that sodium aluminate is soluble, so this aluminium in short is in the soluble part. Okay, right? So this is not, so our aluminium is not in the insoluble part. Correct? We are sure, pretty sure about it because of this reaction. So what we would do is simply discard this insoluble part, and this is where we have removed, see, insoluble impurities. Okay, clear? Now this insoluble part, okay, is actually called as red mud because it is in red color. Okay, because of this ferric oxide. Okay, so this red mud has ferric oxide, sand, etc., etc. Okay, now what we did is we have just removed this insoluble part. Okay, how we would remove it? By filtration. So we would just filter out entire thing. Okay, we would get this NaAlO2 solution. Okay, and this impurities would remain in the funnel itself. Very simple. Okay, now with the help of this NaAlO2 solution, now we are going to carry out the third step, right? So let's move on to the third one. Okay, now what we are having? We are having this NaAlO2 solution, right? But don't get fooled, right? Because see, what we have done is we have added bauxite, we have added concentrated NaOH, okay, in bauxite, right? Here in the step 2. So we know that the part which is insoluble, okay, is simply the impurities because our aluminium is in the soluble part. So that's why we have extracted the soluble part. But there may be some compounds which may also be reacting with sodium hydroxide, okay, which are present in the bauxite because our bauxite is impure, right? So it may have some compounds which may even react with this sodium hydroxide, and they may get dissolved also. So in our this NaAlO2 solution, there may be some impurities as well, okay, which are soluble. And here our role comes to remove these soluble impurities now. Okay, now how to remove these soluble impurities? Once we have removed this, our job would be almost done. Okay, but for that what we would do is we would just take this NaAlO2 solution along with these impurities which are soluble in this solution, okay, and we would just dilute it. We would add some water in it. Okay, dilution means adding water in it, and then we would cool it to 50 degrees Celsius. Okay, we would dilute it with water and then cool to the 50 degrees Celsius. Now what would happen now? Hydrolysis would take place. Okay, now this would be a new term for you maybe. So what is actually hydrolysis? Hydrolysis means, see, the name suggests, lysis means breakdown. Okay, this way you have to remember the thing. And hydro means water, right? So here in hydrolysis, we have added water here. So this water is breaking down our sodium aluminate. Okay, now let's try to figure out how it is breaking down, because that reaction would only help us to conclude that what actually is happening here. Okay, so our sodium aluminate, okay, water is breaking down this sodium aluminate. How it is breaking down? It is breaking down into, see, this two compounds. First one is aluminium hydroxide, okay, which is which is formed and it gets settled down. Okay, so we can say that it is a precipitate, right? We have studied this. The insoluble part is a precipitate. Okay, and the next compound which would be formed after the hydrolysis of NaLO2 is NaOH, simply sodium hydroxide. Okay, now we also have water, so NaOH solution would be formed. Okay, so this means that after cooling to 50 degrees Celsius and after adding the water into it, which means diluting it and then cooling it to 50 degrees Celsius, what we would get is, we would get a aluminium hydroxide precipitate, and this precipitate would then settle down at the bottom. Okay, and the remaining part, NaOH solution, would be there. So here it would be the NaOH solution, and also the soluble impurities. Sorry, if I would have written it here insoluble, it is here soluble. Okay, and also the soluble impurities which were present, okay, they would be still here itself. Why? Because see, here this is the aluminium hydroxide precipitate. Now our aluminium is in this precipitate. See, so now we are least bothered about whatever is there in this solution or in this soluble part. We are least bothered because we are now pretty confirmed that because of this reaction, we know our aluminium would end up in this precipitate. All the aluminium is trapped here, okay, out of these two products. So we know our aluminium is here safe. Whatever there is present in this NaOH solution, that is the soluble impurities which were present here also. Okay, so we would just simply, what we would do is, we would filter it. Okay, after filtering, we would get AlOH thrice, aluminium hydroxide. Okay, this is called as aluminium hydroxide. You may be knowing its name. Okay, and after filtering out, we would get this NaOH solution along with this soluble impurities. Okay, but now this time we are actually going to use this. Okay, here this soluble impurity along with NaOH solution, we are going to use it. How we are going to use it? We are going to take the same filtrate. Okay, what is filtrate now? See, once we have emptied this content into the funnel, okay, so whatever our aluminium hydroxide is there, it would be trapped here, and whatever the remaining soluble part is there, okay, it would just get collected in this beaker. Okay, so this is called as filtrate. Now what would be trapped? Aluminium hydroxide would be trapped, and the soluble impurities along with NaOH would be here. Okay, so this part we call as filtrate, and since this is present here, soluble impurities along with NaOH, so this is filtrate. So this filtrate we are again going to use in the step 2. Now what was step 2? Step 2 was, we are adding bauxite into concentrated NaOH solution. Now this is also NaOH solution, right? We are getting NaOH only here, but it is not pure. It has some soluble impurities. But now in the step 2, we don't care about the soluble impurities, right? In the step 2, we only care about sodium aluminate being formed, and since sodium aluminate is also soluble, so we actually use all the soluble part in the step 2. Remember, we are discarding the impurities in the step 2 which are insoluble. So here in the step 2, we don't bother about the soluble impurities, because finally in the step 3, here we are going to remove again the soluble impurities. But now we again think about the hole in our pocket. So that's why we are using this NaOH as well, okay, which is getting formed here, because we don't want this NaOH to get wasted. Okay, this NaOH can again play a role. It can again react with bauxite, right? Further, though the soluble impurities are present here, we are by the way going to remove them in the step 3, right? So that's why we just save our NaOH and use it in the step 2. Clear with this part? And now let's move on to the step 4. Now what we have got? We have got aluminium hydroxide precipitate, correct? This one in our step 3. So we are going to now convert this into alumina, right? Remember, in this process we are going to convert bauxite Al2O3.2H2O to this Al2O3 alumina. But how we are going to convert it? Very simple step. This aluminum hydroxide precipitate which we have collected, okay, we are going to wash it just like our clothes. Okay, then we are going to dry it just like our clothes. Okay, simply. And then after washing and then drying, okay, this aluminum hydroxide precipitate, we are going to heat it. Now we are going to heat it at 1000 degrees Celsius. Now very high temperature. Okay, so this aluminum hydroxide We are going to heat it at 1000 degrees Celsius. Okay, my degree went too much big. 1000 degrees Celsius to form, it would give us alumina and water. Okay, and finally we would get our alumina. Okay, now what rest is, you have to just simply balance this reaction. Clear? So this is the condition which is important in this reaction, and our job is done. Okay, in the previous one, this is the reaction. Okay, in the step 3, you need to balance this reaction as well. Okay, what is actually happening in the step 3? This is happening, and you need to balance this reaction. Fine. Now we are done with the Bayer's process. We have got our alumina finally. Now let's see some questions based on this Bayer's process. Okay, so that we would get a fair idea that how questions are being asked. Okay, see, first one is Bayer's process is used to concentrate bauxite ore. Now here concentrate simply means purify. Okay, purify bauxite ore. We all know these things. Yes, Bayer process is used to purify bauxite ore to alumina. Just now we have done this thing. Then give balanced chemical equations. Fine. For the reaction taking place for its conversion from bauxite to alumina. Right. Now whatever 4 steps we have seen, the first step doesn't have any reaction, but second step, right? Step 2, step 3, and the step 4, just now we have seen. All these 3 steps are having some reactions, and they are asking simply the balanced chemical equations, okay, balanced chemical reactions, okay, which are taking place for its conversion from bauxite to alumina. So we have seen these 3 steps are having some reactions which are showing the conversion of bauxite to, which are showing the conversion from bauxite to alumina, right? And we have already seen this, all the 3 reactions, okay. You can go back in the video, you can refer those reactions. I have put a box around those reactions as well, and then you can just write it and you can just balance it on your own. Balancing part is now pretty easy. Okay, they are simple reactions. And yes, don't forget to write the conditions, the temperature and the pressure conditions. Whichever reaction it is having the temperature and pressure condition, you write it in the exams, otherwise you would lose marks. Okay, now let's see some next questions. Write a balanced chemical equation for the following. Fine. Action of heat on aluminium hydroxide. So action of heat on aluminium hydroxide. So this is our aluminium hydroxide. Just now we have seen when we heat it, what we get, alumina and water, right? And you need to balance this reaction. You would get a balanced chemical equation. Just now we have seen it. The 4th step reaction. Next is name the most common ore of the metal aluminium. Most common ore of the metal aluminium, from which the metal is extracted. Now very simple. Bauxite, we have studied it. All the things are starting from the bauxite only, right? What they are asking us, write the chemical formula for the ore as well. Now we all know the chemical formula. Okay, you can just write it on your own. We have seen it a lot of times. Next is name the process by which impure ore of aluminium, fine, gets purified by using concentrated solution of alkali, right? Just now we have seen the entire process, and they are just simply asking the name of this process. Right, so such simple questions are also being asked in your exams. They just test that how your concept is strong. So answer would be the Bayer's process. Okay, so friends, with this we have reached the end of this video, and I hope you would have understood all the concepts of this chapter which we have learned so far in this video, right? And you would have also enjoyed learning with me, because I truly enjoyed teaching you all these topics, all these concepts. But please do let me know this thing in the comment section. And as you all know, LearnoHub matlab free hai par best hai. So stay tuned. We will meet in the next video with the next chapter. Till then, bye-bye and have a great day.